Okay, so in this video, I wanted to go through the second half of this lecture. I'm going to cover this in class, but I want to kind of give you a little bit of a head start if you're interested in that, because there's going to be a quick turnaround between when I cover this on Wednesday and when we take the exam on Friday. So to start, a chemical change or a chemical reaction is when a substance is converted into something new, one or more new substances. And these substances are going to have different properties and formulas than the original substances. And a way to represent a chemical reaction or a chemical change is with a chemical equation. And we do this by representing what are known as reactants. These are the things that are reacting. And products. Those are what you get after the reactants react. Okay, so let's talk about kind of how a chemical equation is set up. So when you write these, you have the reactants on the left side of an arrow, and the products are written on the right side. And like I said, an arrow separates the reactants from the products. If you have multiple reactants or multiple products, you separate them with a plus sign. And then if you see this delta sign above the arrow, this indicates that heat is being used during the reaction. Also, you'll see this, sometimes I don't write them just because I'm lazy, but the proper way to write these equations is to also denote the physical state of matter. So if it's a solid, you have a little s in parentheses after the reaction or the product that's solid. Same thing for liquid, same thing for gas. And if one of these is dissolved in water, you say it's aqueous, AQ. Now, these chemical equations, so here's an example of a chemical equation up here. They have to be balanced. And what that means is, if you have one carbon on the left side of the arrow, you have to have one carbon on the right side. Okay, you don't lose or gain any elements or any atoms of these elements during a chemical change or a chemical reaction. And that's due to the law of conservation of mass, which says that mass must remain constant. Okay, so again, if you have two oxygens over here, you need to have two oxygens over here. And this can be tricky when I teach you how to balance equations, but you just kind of have to get some practice and you'll get the hang of it. So this one is worked out for you. This is from a textbook. So write the balanced equation for the formation of Al2S3. So here is our equation. Al plus S, this essentially means equals, but becomes Al2S3. Okay, this is called a combination reaction. And what you want to do, the first thing you're going to want to do is you're going to want to count the atoms of each element on both sides of the arrow. So for example, over here, how many aluminums do we have? We have 1. How many aluminums do we have over here? We have 2. So that's not balanced. How many sulfurs do we have over here? We have 1. How many sulfurs do we have over here? We have 3. So that's not balanced either. And the way we balance this is by writing coefficients in front of the element or the compound that needs to be balanced. Okay. So, for example, since we have 2 aluminums over here and only 1 over here, we can balance this by just writing a 2 in front of aluminum. Same thing with sulfur. Since we have 3 over here, we can just put a 3 in front of the sulfur. So then you check to make sure everything's balanced. So basically you count again. How many aluminums do I have over here? I have 2. How many aluminums do I have over here? I have 2. How many sulfurs? 3. How many sulfurs? 3. So that's balance. Now you want to make sure that you have the lowest ratio of coefficients. Okay, so 2 and a 3. This one is pretty simple, but you'll see later that the more we practice, we'll practice a lot of these in class, and I'll talk more about making sure you have the lowest ratio of coefficients. So let's do one practice here. So balance the chemical equation when solid iron oxide reacts with hydrogen gas to produce solid iron and water. So we have Fe3O4 plus hydrogen gas, which is H2 because hydrogen exists as a diatomic molecule. And then we get solid iron plus water. And we're going to do the same thing we just did on the last one. So you count over here. How many irons do I have? 3. How many oxygens? 4. How many hydrogens? 2. And do the same thing over here. How many irons do we have? We have 1. How many oxygens? We have 1. And how many hydrogens? We have 2. So we can see that iron is not balanced, oxygen is not balanced, hydrogen's balanced for now. So let's try putting in some coefficients and see what we come up with. So let's balance this iron first. So we have 3 over here and we only have 1 here. So what we're going to do is we're going to put a 3 in front of iron. So now that's balanced for the moment. And then let's try oxygen. So oxygen has 4 over here and then there's only 1 here. So what we're going to do is we're going to put a 4 in front of water. Now, you cannot put these coefficients in the middle of a compound. It has to go in front of the compound. And when you do that, it distributes to every atom in that compound. So now we have 8 hydrogens. It just multiplies. And now we have 4 oxygens. So oxygen is balanced. But when we balance this, when we balance oxygen, now we have 8 hydrogens and only 2 here. So what we're going to do is we are going to put a 4 in front of this hydrogen. Okay, again, this is 8. This just multiplies. So we go back and we count. We see we have 3 irons, 4 oxygens, 4 oxygens, 8 hydrogens, 8 hydrogens. So this is a balanced equation. Now on the exam, what I will do is I will give you the equation and you'll just have to balance it. You'll have to write a balanced equation. And we will practice more of these in class. So if it doesn't make a ton of sense right now, that's okay. You know, you're welcome to work on the practice problems, work on the homework, and practice this on your own. Alright, let's just talk quickly about types of chemical reactions. The first type are combination or synthesis reactions, sometimes called anabolic reactions, at least in biology. And this is when you have 2 or more elements or compounds that come together to form a new product. So for example, sulfur plus oxygen gas equals sulfur dioxide. Okay, A plus B yields AB. The next type is a decomposition reaction. This is kind of the opposite. These are also known as catabolism reactions in biology. And this is when you have a reactant that's split into smaller products. So AB yields A plus B. It's just the reverse of a synthesis reaction. Then we have replacement reactions. And this is when elements are basically switched with elements in another compound. And you can have single replacements or double replacements. So a single replacement, this is when reactions only involve one switch of an element. So for example, down here we have A plus BC, and this yields AC plus B. So essentially what happened is A came in, kicked B out. And then in a double replacement, there are 2 switches. Okay, it's like you're switching dance partners. A plus B, or AB plus CD yields AD plus CB. So you just switch the dance partners. That's why they're called replacement. So what type of replacement reaction is this? So we have zinc plus hydrochloric acid yields zinc chloride plus hydrogen gas. Well, we can see that this is a single replacement. Zinc comes in, knocks hydrogen out, and then we get zinc chloride plus hydrogen gas. Combustion reactions. This is when you take a fuel or a carbon-containing compound, in this case methane, and in the presence of oxygen, you burn it to form carbon dioxide and water. So this slide is actually a fun fact slide talking about the production of carbon monoxide. I don't exam over this. This is just more for your own knowledge, but I'll talk about it really quickly. So when you have a propane heater, propane of course is a gas, or a fireplace, you know, wood is a type of gas. You need adequate ventilation. That's because when the oxygen supply is used up, you have incomplete combustion. And when you have incomplete combustion, you get the production of carbon monoxide. So you always hear about car engines. You know, car engines are relatively inefficient. And since they're inefficient, they incompletely combust, and that's why you get the production of carbon monoxide. And the problem with carbon monoxide is it basically outcompetes oxygen for binding space on hemoglobin. And the problem with that is if it outcompetes oxygen, you're not delivering oxygen to your tissues. And of course, this can be fatal. Okay, let's talk about oxidation-reduction reactions really quickly. These are commonly called redox reactions. And this is when you have the transfer of electrons from one substance to another. Oxidation involves the loss of electrons from a substance. Reduction is the gain of electrons. And the easy way to remember this is oil rig. Oil, oxidation is loss. rig, reduction is gain. And that's pretty much the extent that you'll need to worry about. If you know oil rig, you will be fine. So as you can see by this little diagram down here, oxidation is the loss of an electron, reduction is the gain of electron. So we say that B is reduced and A is oxidized. So you won't see anything like this on the exam. It just helps you to get familiar with the concepts of oxidation and reduction. So here we can see that we have lost electrons. These electrons have been lost, and therefore it's oxidation. Here we have actually gained electrons, so this is reduction. And same thing down here, this is reduction. This is just showing, redox reactions are completely vital for biology, extremely important for almost everything. I'm not going to talk about this in detail, but just know that they're very important. Okay, now the concept of the mole. So the mole is a unit of measurement for the amount of a particular substance. This substance can literally be anything. It can be a molecule, it can be an atom, it can be an ion, it can be a pencil. You can have literally a mole of anything. And it's given by a constant called Avogadro's number, which is 6.02 times 10 to the 23rd. And what that means is a mole of a substance, whatever it is equal to 6.02 times 10 to the 23rd particles of that substance. And we can see our conversion factors down here. So for example, 1 mole of pencils is equal to 6.02 times 10 to the 23rd pencils. 1 mole of water molecules is equal to 6.02 times 10 to the 23rd water molecules. 1 mole of gold atoms is equal to 6.02 times 10 to the 23rd gold atoms. So the mole is actually very useful, and we're gonna be working with this in a little bit. So how many CO2 molecules are in half a mole of CO2? Well, we know that 1 mole of CO2 is 6.02 times 10 to the 23rd, so basically you just divide that by 2. So it's 3.01 times 10 to the 23rd. So a couple of problems here. I'm not going to talk about this right now. I kind of want to move forward and talk about molar mass, which is going to be more important for our purposes. So the molar mass, this is the mass in grams of 1 mole of an element. So the molar mass is expressed in grams, and this is found on the periodic table. It's actually the same thing as atomic mass that we've talked about before. So for example, 1 mole of carbon atoms is equal to 12.01 grams. All right. So what is the mass of 1 mole of hydrogen atoms? Well, it's just going to be a little bit over 1, the atomic mass of hydrogen. So as you can see here, the molar mass of silver is 107.9 grams. Same thing for carbon, sulfur. It's just the same thing as atomic mass. So we can do a little bit of calculating here. So what is the molar mass of nitric oxide, a potent vasodilator, which is really an interesting little chemical in our bodies. So what you do is you find the molar mass for each of these. Nitrogen is about 14, and then oxygen is about 16. Oops, let me erase that. Then you just add them up. So you say the molar mass of nitric oxide is approximately 30 grams per mole. Okay, so this problem is a little different. A box of table salt, sodium chloride, contains 737 grams of sodium chloride. How many moles of sodium chloride are in the box? So again, what we're going to do is we're going to find the molar mass of sodium chloride by adding up the individual molar masses of each of the elements. So sodium is about 23 or so. And chloride is about 35.5. Again, you add these up. And our molar mass for sodium chloride is about 58.5. Okay, that's grams per mole. Now we're looking for moles. And we have how many grams of sodium chloride are in the box. So if we're looking for moles, all we have to do is divide. So 737 divided by 58.5. Okay, this is grams. This is grams per mole. When we divide, these cancel, and that leaves us with moles, and that's going to be somewhere about 12.6. Okay, so we can do different things with these problems. A related kind of topic, and this is actually coming from a different chapter, but I want to throw it in here, is molarity. So molarity is a measure of concentration. Concentration is basically the amount of a solute in a solution. So it states the number of moles of a solute in a liter of solution. Okay, we just learned how to find moles using molar mass and a mass of a particular compound. Now we can find molarity, how much of that is in a particular liter of solution. So this one's worked out. What is the molarity of a 0.5 liter solution of sodium hydroxide if it contains 6 grams of sodium hydroxide? So the molar mass of sodium hydroxide is about 39.997. And we have 0.15 moles of sodium hydroxide. Okay, we get that from dividing the 6 into the 39.997. And then we're already given liter of solution, so you just divide them. Okay, so it's a 0.3 molar solution of sodium hydroxide. We will actually practice more of these in class, so if it's confusing right now, don't worry about it. Obviously, I will teach all of this in class. And then finally, energy in chemical reaction. The heat of reaction, also known as the enthalpy of reaction. This is just the amount of heat that's either released or absorbed over the course of a chemical reaction. Exothermic, exo meaning out, exothermic reactions, this is when the energy of the products is lower than the energy of the reactants. What that means is heat is released in exothermic reactions. Endothermic reactions, endo means within, this means the energy of the products is higher than the energy of the reactants. What this breaks down to is heat is absorbed in these reactions, which we can see here. So this is an exothermic reaction where the energy of the products is less than the reactants, so energy is released, heat is released. And this is the opposite. So this is an endothermic reaction where the energy of the products is greater than that of the reactants, so energy is absorbed. This last slide about cold packs and hot packs is just a fun fact slide talking about how these kind of tie into exothermic and endothermic reactions. So again, I know this was brief. This is just to kind of give you a little intro into these topics. Again, I'm going to teach all of this again in class. I recommend that you try your best to understand what I've presented here. I know it's really fast, but I recommend looking into these topics because it's going to be a really quick turnaround for the exam. So as always, if you have any questions, please let me know.